Right, here we go. So we've got an inclined plane with a block of mass 0.2 kilograms and it's at rest and it's rough. Okay, so we're going to think about friction. Right, the plane is inclined at an angle of theta to the horizontal such that tan theta is 7/24. So if we were to draw a little right angled triangle, then we've got tan theta, if that's theta, opposite over adjacent, 7/24. We can work out what our hypotenuse is. Have you worked that out yet, Dan?
No, I'm on the question.
I've not got a calculator, hang on, let me pause. Thanks, George. Okay, and that will give you 25. Right, okay, so we know that sine theta is opposite over hypotenuse, whoops, and cos theta is adjacent over hypotenuse. Right, might not need that, but we might as well write it down. Right, there's a smooth fixed pulley at the top of the slope. B is released from rest so that it begins to move vertically downwards. Okay, so it's going this way. So the block will be going that way. The weight of that will be 2g. The mass of the block, we're going to have to split up the weight bit into the, into the vertical and the parallel and perpendicular components here. So we've got 0.2g cos theta coming down and 0.2g sine theta acting parallel to the slope. And we'll also have a reaction force. And because this surface is rough and it's going up the plane, you've also got friction opposing this motion here, so you've got friction acting down the plane there. Now the string is pulling this up the plane and it's trying to stop that weight falling down there, so we can label our tensions like that. And now we should have a fully labelled diagram now. Right, the B is released from rest so that it begins to move vertically downwards with an acceleration of that. Show that the coefficient of friction between A and the surface of the inclined plane is 0.17. Okay, so let's do F equals MA first of all for this little bit here, for B. Okay, so the positive force is 2G, got the tension in the cable coming up, and that is equal to 2 times 543 over 625G. That's horrible. Okay, now let's do F equals MA for A. So it's going up the plane, so the tension is our positive force. Friction is coming down, so we're going to take that away, and we're also going to take away that 0.2g sine theta. And that's equal to the mass, which is 0.2 times that acceleration again, 543 over 625g. Right, okay, so we've got two equations, so we need a third. So we're going to use that friction is equal to mu times r. Okay, so if we resolve vertically here, the only vertical force we've got going up is the r. The only perpendicular to the plane force there is r, and that must be equal to 0.2g cos theta. So friction is equal to the coefficient of friction, which is mu, times 0.2g cos theta. Okay, so now we've got three equations that we can use. I'm going to use a combination of these three equations to find mu. Okay, so it's a show that the coefficient of friction is 0.17, so we want to rearrange everything to get it in terms of mu on its own. So we're going to need to use the three equations I've just highlighted there. So the easiest way to do that is to get, well, first of all I want to get rid of these t's. So I'm going to add this equation 1 and equation 2 together. If I do equation 1, add equation 2, I get 2g minus t plus t goes away, So minus the friction minus 0.2 g sine theta equals, so I've got 2g times that, add 0.2 times that, so I've got 2.2 lots of 543 over 625g. So I think it's time to do some working out now. One moment. I've got 2g times this over here, so I'm going to take that away. No, I'm not. First of all, I'm going to work that out. I'm going to stop taking shortcuts. Times 543 over 625, so 1.91136g. And I'm going to take that 2g over to the other side, so take away 2g, add 0.2g sine theta, and that will give us the friction. All those added together, so we've got 1.91136 minus 2 lots of g. Oh, these numbers are awful. So minus 277 over 3125 lots of g plus 0.2g sine theta. Okay, equals g times minus. I'm just factorising g here because I think when I go over the other side I'm going to cancel some g's out. Okay, so now I've got a new equation here now. That's what my friction is equal to. Whoops! That's what my friction is equal to. So now I'm going to pop that into here because I've not used this equation yet. And I want to get mu on its own, so I'm going to rearrange that equation. Go over here a minute. I'm going to rearrange this equation, so I've got my friction over 0.2g cos theta is equal to mu. So I've got g times plus 0.2 sine theta all over 0.2g cos theta equals mu. So the g's cancel out. Right, so what can we do next? I want mu on its own. Where I'm going is I want sine theta over cos theta, I think, because I want them to... Oh, hang on, I know sine theta up here. I worked those out right at the start. Silly me. Right, so I've got minus 277 over 3,125 plus 0.2 times 7 over 25. I probably should have replaced those ages ago. And that would have made life a lot easier. Right. I'm just going to go and calculate that and make sure it's 0.17. 1 minute. Right, I can see where I've gone wrong. I actually made a bit of a mistake, so I got a negative answer. So, with the help of Dan and George, I've gone back and realised that here, when I've rearranged this equation here, this is minus FR. So that is minus FR there, and so what I should have done was make that positive. Where should I have made that positive? Come on, Louise, where's that positive? Anyway, so that's where I've gone wrong. So I think that's positive and that's negative. That's right. So you get mu is positive 0.17. So apart from that little slip up there, which I would have lost maybe 2 marks for that, naughty me, the rest of it was pretty much spot on. Thanks, Dan and George.